The Genuine Article. Discussion and commentary based on articles from JACC.
Hello, I'm Tony DeMaria, the editor of JACC, and I'm here with another edition of Inside JACC. And on this occasion, I'm talking to Sam Tsimikas, who, of course, is one of our associate editors of JACC, and now he's stepping on the other side of the table, and he's an author of a really important and interesting paper that's about to appear in JACC that deals with oxidation-specific biomarkers. So, Sam, I think the general cardiologist probably is not so familiar with oxidation-specific biomarkers. Can you tell us a little bit about them?
Thank you, Tony. These biomarkers that we're talking about are emerging biomarkers, and there's been a whole series of these in the past, but the ones that are in this paper that I think the most validated at this point, and there's several of them that we've studied, including oxidized phospholipids that are very important in atherogenesis and plaque destabilization, lipoprotein a, which is also in the realm of emerging biomarker, but it's really coming forward as a clinically relevant potential target of therapy. And then there's some phospholipases that break down either oxidized phospholipids or their carriers like LPA, such as LPPLA2, phospholipase-associated A2, or secretory phospholipase A2, which are enzymes that break apart oxidized phospholipids. We also looked at myeloperoxidase and CRP in this particular study and put them all in a model to try to predict cardiovascular risk with all these in combination, as opposed to previous studies which have looked at individual biomarkers in a particular data set.
Well, of course, we're always looking for risk stratifiers for coronary events, and I think you exploited the Epic Norfolk population.
That's right. This is a population based in England, initially designed as a cancer study of 25,000 patients, but because they were recruited at age 65 or so, we were able to look at cardiovascular outcomes, and this is a nested case control study within that larger population. In this particular study, we have about 2,700 patients where we looked at 6-year follow-up of cardiac events, and all these patients were initially recruited being healthy. So it's an epidemiological cohort that allowed us to look at prospectively the role of these biomarkers in risk prediction.
And the events, of course, consisted of?
The events were death and cardiac death and myocardial infarction, and basically heart events related to coronary artery disease.
Really heart events. Well, what did you find?
What we found is that the two major parts of the study was the oxidized phospholipid biomarkers and the LPA were independently predictive of the primary endpoint, and the odds ratio was about 1.7, independent of other risk factors. This was also independent of Framingham, or added value to Framingham, and it was independent of CRP and other traditional things that are usually measured. The second thing that we did is we took all the biomarkers and put them in one model and try to assess their incremental value above and beyond, measure them individually. And what we found is that when you look at these biomarkers in tertiles, that combinations of them, because they're pathophysiologically related, allow us to enhance or double the risk ratio to about 3.5 to 4, by having, say, oxidized phospholipid with secretory PLA2 in the same model. So by themselves, they're independently predictive, but as a combination, they're additionally predictive, doubling the odds ratio. We then looked at them in the Framingham risk model, and each one of these biomarkers, to various extents, allow you to further reclassify, in a sense, the risk that you have within each Framingham tertile. So it gives you information above and beyond Framingham, and furthermore, if you put them in a C-index model, each one of these incrementally allows you to have increased area under the curve for prediction of cardiovascular events.
Well, these biomarkers certainly look very attractive. They look very attractive compared to some of the other biomarkers like CRP that we're talking about. Do they provide a target, perhaps, for therapy?
That's a great question. In fact, they do. So there are now trials looking at inhibiting LPPLA2 enzyme activity, and there's several phase 3 trials going on to look at that. The SPLA2 is also secretory PLA2 is also a target of therapy. Also in a phase 1-2, it's a little bit behind, but it's also coming along. And LPA now, there's a lot of interest in LPA and oxidized phospholipids because they're highly interrelated. And we're not at the level of trials yet, but there are now some specific agents that you'll be seeing coming down the road that lower LPA levels, which is really a very large unmet need because about 30% of the adult population in the U.S., the Caucasian population, has high LPA levels. It's a genetic risk factor, so it starts at birth. And in a lot of our young patients, it's particularly an important risk factor. And eventually, we may be able to do a trial in patients with high LPA where we could lower it and see if that reduces cardiovascular risk.
Well, this is really exciting, Sam. It's clear that as cardiologists, all of us are going to have to become very conversant and familiar with oxidation-specific biomarkers. They are potent risk stratifiers and perhaps in the future important targets for therapy. Thanks for sharing this with us.
Thank you.
For Inside JACC, I'm Tony DeMaria.